Hi guys, this is Hamza Azmi. I am a third year computer engineering student from Sabu Siddiq College of Engineering. In this webinar, I intend to explain a very basic and important concept in operating system. This concept also plays a very important role in computer architecture and organization. This topic is nothing but the various page replacement policies. So I'm going to open this Word file. I'm going to be teaching this with the help of a few examples. Once we are able to solve the example, we get a clear idea of what these policies are. So let's begin. The first question that comes into our mind is, what are these page replacement policies? Why do we need these policies, and how many policies are there? I'll answer this. Now, in the computer system, there are two types of memories. One is the main memory, and another is the secondary memory. Whenever your computer has to perform any operation on any data or any files or any pages, and those pages are located in the secondary memory, then the CPU gets those pages from the secondary memory into the main memory and performs the operation that it has to perform on them. Another interesting thing is that the main memory compared to the secondary memory is small in size. Even though it's fast, it's very small. Therefore, after a certain point of time, there will be no space available. There will be no frames available in the main memory. In a situation like that, we have to replace the incoming pages with the pages which are already present. It is at times like these when the page replacement policies have to be used. Now, answering the question, how many page replacement policies are there? There are three page replacement policies that we will be dealing in this webinar. The first one is the LRU, the first one is FIFO. We'll go in an order from easy to tough. Or you can also say from least optimal to maximum to the most optimal page replacement policy. The first one is FIFO, first in first out. The second one is least recently used, also called as LRU. That's the short form, that's the acronym basically. The third one is optimal. So the best one is optimal, the second best is LRU, and the third one is first in first out, that is FIFO. Now, as y'all can see on the screen, y'all have reference string and y'all have frame size. Now, for the sake of example, I'm going to assume that there are only 3 frames available, and these are the pages that I have to put in these frames as and when the CPU requires. So I'll directly start solving the sum. So initially you can see that the 3 frames are empty, so I do not have to really bother as to where I have to insert the incoming page number. So I'll directly put 0 over here. Now I have 2 frames left. Now I will write a miss below this. This is because the page wasn't already present. It had to load it all the way from the secondary memory. Now the second number that comes in is 2. This also accounts for a page miss. The next number that comes in the frame or in the memory is 4. This also accounts for a miss. Now here is where the actual algorithm comes into play. When I'm saying first in first out, in simple terms it means what came in first has to go out first. Now I'm running short of space, so I have to remove something in order to make space for something. So the trick to solve sums like these is to pay more focus, is to pay more emphasis to the previous records, that is these columns. Clearly from this you all can see that 4 came in early. Before 4 it was 2, and before 2 it was 0. So I'm going to replace 0 with 6, and the other 2 numbers remain the same. The next number which enters is 2. Now where should I put 2? Isn't 2 already present in the memory? I don't have to replace it, it's already present. So I write 6, 2, and 4 over here, just the way it is. However, this time it will be a page hit. Now I am encountering a problem again. Now 0 is not already present, so I have to replace it. 4 was the latest page number to come in. Before 4 it was 6, and before 6 it was 2. Therefore I will replace 2 with 0, and the other two numbers remain the same, and this also accounts for a page miss. The next number that comes in is 9. Again I'll follow the same thing. 0 is the latest page number. The number before 0 was 6, and before 6 it was 4, so I'm going to replace it with 4. Now moving on to the next one. 9 was the latest page number. Before 9 it was 0, and before that it was 6, so I'm going to put 5 over here, and we will follow the same route and we will solve the whole sum. So the next number will be 965. I'm going to replace 0 with 3, and this accounts for a page miss. The next number which enters is 8, so I need to make space for 8. This is how I do it. This accounts for a page miss again. The next number is 1. 1 is not already present. I'm going to replace it with 5. Accounts for a page miss again. Now I have 8, I have 1, and I have 3. I need to make space. 1 was the latest number to come in. Before it was 8, and before that it was 3, so clearly I'm going to replace 3. Accounts for a page miss again. Now in the memory I can see in the 3 frames 1 is already present, so I do not have to add it again, so this will become a page hit. And the last number is 7, that is the last number in the reference string is 7. As you all can see that 7 is already present in the second position. I don't have to add it again, so this accounts for a page hit, and this is how I solve the sum. So this was first in first out, that is FIFO, page replacement algorithm. The next algorithm that we will be learning is least recently used.